Oh, right now? Super. I see the full house, so really nice to see you there. My name is Łukasz Husarz. This is my friend Marcin Paluszek, and today we want to share the story of how we moved our game servers from classic bare metal infrastructure to Kubernetes, and we will show you what problems we had before, how we solved them, and what we learned along the way, and I think you can take something away for you.
All right, so what did things look like before we started our journey? Let me quickly show you our legacy architecture, and I will just cover the most important parts. We have a lot of servers, dedicated servers, running different types Java-based game components, and the core of the games are game servers instances. Next are services, and they are really important, so we are trying to keep them on separated host. We have also special hosts for arbiters, but I will talk more about them later. Next are utility hosts. They run our tools or maintenance scripts. HA proxy is our load balancer. It routes traffic to the game servers instances and services instances. We of course have database hosts, but they are not migrated yet for some reasons, so let's skip them now. And everything is managed by Puppet. What can I say about this setup? It looks solid, works pretty well, and to be honest, we really didn't have a lot of issue with that configuration. But recently some on-prem daemons started showing up more and more. And speaking of daemons, we are in Romania, right? So if we are talking about our daemons, let me show you the first one, and its name is Arbiter. Arbiter is a very specific service. We didn't have time to go into all the details, but in short, it takes care of some of the game's most important features, which means it's absolutely essential. Without it, the game simply doesn't run. And to make it even harder, only one instance can run at a time. So implementing good and fast working failover or redundancy, in our case with all our requirements and restriction, is, let's say, it's complicated. So to sum it up, it's a classic single point of failure. And now imagine that one of the write disk fails on the host running the arbiter, so we have to request disk replacement on this host, and we have to move the arbiter. How does it work? Very fast and easy. We only need to find a new host with enough free resources and prepare it using Puppet. It takes some time, maybe not the whole day, of course, but still maybe 1 hour. Once we've got host ready, we need to wait until midnight, because that's when player traffic is lowest. And as I already told you, stopping arbiter means that entire game stops. So we cannot do this in our peak time, right? Once we've got host ready, we have to go through several important steps, always with close coordination with one of our developer. And that's not all of them anyway. There are more, like switching database connection, but let's just say these are the most important ones. Once we finished our migration, we also need to remember to clean up the old host, just to be sure that old arbiter instance doesn't accidentally restart. So yes, I was joking with that fast and easy at the beginning, but hey, it always could be worse, right? Because last time we saw we lose a disk, right? What about now? What if we lose the entire host? Right now, the game is down. So we are not waiting until midnight. We have to respond right now. We have to go through all these steps as soon as possible to bring the game back. And at this point, this is pretty much what we look like. Pretty stressful situation, right? But if we are talking about stressful situation, let's talk about another one. Let's talk about next demon, about scaling. And I have another real example from our company. We had situation that we launched featuring in big country. It was India specifically, so quite a big country with a lot of people. And in first month alone, we recorded a huge number of new game installs, which was significant percentage increase. And that kind of growth made our servers are heating up more and more. And we really didn't want them to end up like this. So we took a number of steps to protect ourselves. First, we tried scale up our setup with adding new game server and services instances, and we used all our spare capacity we had. We also need to change configuration HA proxy to rebalance player traffic across new instances. But even after that, the growth was just too big. So we had to order new additional dedicated host. And when we did it, the featuring in this country was shut down. So we took our time, we took a cost, and we ended with brand new but unused dedicated servers. So we ended like this.
Yeah, so all of those things were frustrating for sure, but not just only for us. Let's imagine the situation that we have 50,000 players online and everything going fine until we find a bug. The 100 players can't log in. 100 doesn't mean so much, but some of them may be our top spenders. Players who pay a lot and expect smooth experience. So we had two options. Option one is to wait for lower traffic, maybe late at night, but that meant the 100 players are still locked out. Option two is deploy fix right now, but that meant a restart of our Java servers, which meant relogin for all players and triggers some lags. None of these options are okay. No matter what we choose, someone will be upset. So let's sum up the pain. First, no self-healing. If something broke, we need to fix it by hand, often at night. Second, no auto-scaling or flexibility. And finally, the third, deployments. As I said, every deployment means restart of Java, which means relogin for all players, which means angry players. So, after enough of pain, we started asking ourselves a question. How we can fix all of this? How we can solve our problems? How we can make our life easier and our players happier? And the answer was quite obvious. Kubernetes. And yeah, we already use Kubernetes on GCP with all of the tools like ArgoCD, Vault, Prometheus, Cert Manager, etc. So we knew it's a power. But we asked ourselves another question. We want the fully managed Kubernetes on GCP with everything ready to go, or self-hosted cluster managed by our own team with full control, but also full responsibility. So, I have a question to you all. What would you choose? Raise a hand for GCP. Okay. Okay. For self-hosted? More of you of self-hosted. Okay. So, we went with self-hosted. Mostly because of the cost. It's around circa 40% less cost than GCP, but also because of the latency. we set up the cluster in the same data center where our databases game lives, so we've got lower latency and save some bugs. Now, you might ask why we choose K3s, why this particular distro. So, we had experience with using Kubernetes, but not that much about setting up cluster and managing. So, we had lack of knowledge, and we wanted something simple, easy to start with lower entry barrier, but also something that fully supports high availability, and it's ready to run real production workload. And K3s gave us that balance. So we treated all of these things like a real project. So at the beginning, we made a plan, we set up with the product team, discuss about the risk, about the success would look like. Then we split up the tasks between the teams, so everyone knew what to focus on. Then we made a simple timeline, how we wanted to move forward, but no rush. No rush because of the tests. We knew that the production stability and our players were our top priority, so we need to test all of the things really carefully. So, we have everything ready. Test environment was up, images were burned, secrets involved, everything, we're ready to go. And we started with Ingress Nginx. Why? Because we knew it, and it works well on our GKE cluster, but soon we ran into some problems. Problem one is to no sticky session based on our custom bottle session header. Imagine like players switching their internet when they are playing from Wi-Fi to mobile on their phone. And that cause players are jumping between pods, breaking their session. Not acceptable for us. Second, no native canary deployment support. This is a really important feature. And the third, funny story, no real preservation of client IP. So in tests, every player looked like they were from Poland. You can only imagine the faces of our R&D guys when they really realize this, all players from Poland. So all of the things can be solved by workarounds or custom solutions, but then we looked at Istio, and Istio gave us everything out of the box. So at every stage of the project, we kept one thing in mind, our players. So we don't want just cool new setup. We wanted something better. So we tracked the key players metrics from just day one. Metrics like how long they played, how many activities they did, how many times they need to relog in, etc. And those metrics help us a lot to compare the new infrastructure to the old one using the real player behavior. So let's talk about one of our demons, deployments. Before, every deployment meant restarting of Java, which means relogging of all platform. Right now, we use rolling update. And when the rolling update starts, the new players are routed to the new version on fresh pods. Players who are already active stay on the old pods and playing without any interruption. The old pods stay alive for 45 minutes, which is more than our average session length. Or, if the session metrics hits 0, it can be shut down earlier. And we control all of this with our custom press-stop script using Prometheus metrics to control sessions. So, we also introduced new deployment methods. And our developers especially loved Canary releases. Why? Because they can deploy a fix or a new version to just small percentage of players and test it. When it works well, it can be rolled out to everyone. And we set up all of this in our Helm charts with simple switch enable false true. And here is how it looks in action. It's a live traffic visualization from Kiali. Kiali is a graphic console for Istio Service Mesh. And you can literally see requests flow with all of the things like response times, error rate, etc.
All right, so here's the undefeated. Excellent news. The next one we have to face was scaling, or rather the lack of it. And of course, Kubernetes comes with powerful tool to fight it, auto-scaling. Thanks to that, we can easily make sure that our servers don't end up looking like this, but like this instead. Okay, but how? With native horizontal pod auto-scaling, we don't have to adjust resources manually. We can define the limits once in our Helm charts, and Kubernetes takes the rest. Here is our baseline. We set a minimum of 5, maximum of 16 pods, and tell Kubernetes to scale up or down based on CPU usage. In this case, it was 80%. It was simple. It works well for predictable traffic, but we needed something smarter. And here comes KDA, Kubernetes event-driven autoscaler. With KDA, we can scale not based only on metrics like CPU, but also on events or time-based triggers. And this is perfect solution for our games. Why? Because we know that at 15 o'clock in our games, event starts. And it always brings sharp spike in traffic. So instead of waiting for CPU to spike, we can scale before it happens. Here, we start scaling 10 minutes before 15, just to be sure, just to be ready on time. And after half an hour, when the peak is over, it scales back down automatically. So we tested first solution with basic horizontal pod autoscaling. Then we tested KDA, but one day, unfortunately, we tested both of them in the same time. Why not both? We already know. So let us tell you how it went. We have some incident. It all starts with a config change. We thought we had disabled KDA by setting enabled false in our values, but what we didn't realize is that the scaled object and KDA autoscaler were still in the cluster. At the same time, we want to test something, so we turn on the basic horizontal pod autoscaling, and they both started to scale the same deployment. And it looks exactly like this. We blinked, and boom. A whole pod farm just spun up in one moment. And at this point, it wasn't scaling anymore. It was a fight. 2 autoscalers, only one deployment. One scaler was triggered by CPU usage, the other one by cron. Each thought it was doing the right thing, and neither one knew the other exists. So no coordination means no mercy, just chaos. What was the result of this fight? Over 40 pods running, many of them stuck in terminating, some in pending. With that many pods sending requests, our databases got completely jammed. We basically blew up our cluster with own autoscaling, so we can say it was our fatality. What did we learn? Disabling something in your values doesn't mean it's actually gone. So remember, always clean up leftover resources. All right, we unfortunately taken some hits. Let's try to recover now. Let's talk about another fundamental benefit of Kubernetes, self-healing. And it means if something breaks, the system tries to recover automatically without manual intervention. So in case of pod crash, a new one is created. When node fails, workloads is sent to a healthy one. And to handle this even better, we can use props. They are telling Kubernetes when pod is healthy, ready, or needs help. Self-healing minimizes a lot failure risk and downtime, especially after working hours, but it also makes maintenance much easier. Because do you guys remember that story with migrating arbiter? This one with late nights, developers and step-by-step coordination. Well, we didn't have to wait long for a real test. Another disk fails, and this time it was one of our worker nodes. But this time, moving services is fast. How fast? Actually, can I ask all of you for a quick favor? Let's all snap our fingers once at 3. 1, 2, 3, snap. All right? That's it. That's exactly how long it takes now. It wasn't exactly Thanos snap, I hope so. We are still there. But it was almost so powerful. One person, one comment. With just one comment, the cluster take care of the rest and starting moving workloads to another healthy node. We only need to wait until all pods have been terminated. So huge difference with time and effort. And self-healing was the cure for our last demon. So now we can say goodbye to the dark and evil Dracula. And we are still in Romania, right? So welcome, legendary Romanian hero, Fat Frumos. He's now watching over our infrastructure, armed with a mighty weapon, Kubernetes.
Super cool that we have a new hero, because the adventure is not over yet. Right now we are migrating our biggest game, the final boss of the project. Next we want to improve our observability, especially with tracing. Tracing really helps us to understand performance issues across our services. And once all our games run in the same cluster, we can share resources between them, so we can reduce waste and save some money. So that's all from us. Thank you for listening. And if you have any questions, we are open.
Questions? Questions? I have a question, please. So, if you have a failing worker node, let's say a disk failure like you showed in the presentation, can you automatically respond to this event and mark that node as unavailable for Kubernetes? Because I saw that you said that you manually go and mark it as unavailable, so it won't schedule new pods and anything.
This situation was about the lost disk, so I think it's not good to automatically drain this node, because the node is still working but needs some help about replace the disk. But I think it's not in this particular case. When the node is down, it's also of course marked as unavailable. So I think in this particular case, we still do it manually when we choose the time for this.
Situation where the recovery is possible and it's not a big failure.
I think right now we are only aware of the peak times of the game, like the 15 o'clock, so that no, but in the morning or late day it's not problem to drain. We have enough capacity to switch the nodes.
You told us the story about how the arbiter is a very complex thing to migrate. So right now, with Kubernetes, it goes straight, so you're not losing games.
We are still losing games if we are in our peak time, but it take less time because we had situation that arbiter down in weekend.
Okay.
So it was stressful, and you know we had to call someone to fix this.
But right now on the K3s, it's like when the arbiter or node with the arbiter is down, it takes time only to deploy the new version on the second node, like I don't know, maybe 30 seconds. And the 30 seconds is downtime,
Yeah,
of course.
This is
this is this is what we
But
gain.
the process of we need to move the arbiter or to
Yeah,
replace it.
all of the stuff.
Same.
No. We just don't need to do anything. If nodes fails, arbiters deploy on the other node, and game is back online.
You know, I was talking about the intermediate type of error when the hard disk is down and you want to move the arbiter. It's the same process as before.
Only kubectl drain,
Yeah.
and that's all.
Not calling developers or something.
Yeah.
Do you use crons to prepare for peak hours?
Yeah.
In Keda. Just to warm up the infra.
Is there any particular reason why you can't do some cluster election for the arbiter to have multiple replicas running at the same time and elect the leader?
Here is our friend, one of the developers.
Yes. Arbiter is super complicated, and it takes care of really important features like championships or something like that. But if you want more details, so yeah.
But still, it can be only one instance, even on Kubernetes, only one running at the time.
We're running K3s for our thermal testing scenarios, so really short-lived. And so far we haven't reached any bottleneck. Have you ever encountered a scenario where you told yourself, hey, maybe if using Kubernetes would have not caused this issue? Because K3s is a small project and it always has to keep up with the big brother in terms of adopting the API changes. Running 131 might not be the same thing as moving to 133 because it needs to keep up. And running a small project like K3s in production may cause you some headaches. Have you encountered? What's your feeling about it?
We're running K3s, I think, for 1.5 years. First cluster was for our R&D team, and they also have dev environment and also production for all our analytical stuff. Then we run into our games also with K3s, and no incident, no bottlenecks, no problems at all with particular distro, and we keep updates on the main track from GCP. When on GCP we have 131, we have also on K3s 131. When it's update on the GCP, we also update K3s after.
What OS do you use?
OS? Debian. All our infrastructure are on Debian. Databases, all the stuff.
You chose self-hosted. How would that work with the India deployment?
How will this work with India deployment?
No idea.
Still burnt? I don't know.
Yeah.
The story was 2 years ago, I guess. Yeah, 2 years ago.
Okay, so right now we are running blue-green deployment. So the problem with India was that we are running version A and version B of server. So basically, if we had like 6 nodes, then we had like six servers of version A and 6 servers of version B, and only one was used at a time. Right now, we can have like all resources to one version, to the active version. So I think it would be
We will
good.
manage.
Yeah, we would manage.
We have time for one more question, then it's lunch. Be careful. I said the magic words. Well, thank
So thank you all.
Thank you.